Hi everyone, I hope you are all fine. I would like to thank the Committee of Zooming Innovation in Consumer Electronics International Conference 2020 and all the sponsors to give us the chance to present our paper titled as the size and the weight prediction for intact pineapples using a low-cost fission system. The author of this paper are Hasan Ali Jamal Kaf, Chia Seng, and Faiz Ridwan bin Abdul mubin. And I am the presenter. My name is Hasan Ali Jamal Al-kaf. First, I would like to discuss about the importance of pineapples. Pineapple is the third most important tropical fruit in the world. It is known as the queen of fruits due to its excellent flavor and taste. It is good for digestive system and helps in maintaining ideal weight and balanced nutrition. The pineapple is a tropical edible plant and the most economically significant plant in the family of Bromelaceae. In Malaysia, there are more varieties of pineapples. Example, N36 and Sarawak and more. All the varieties have different of sweetness and acidic. The main type of pineapples in Malaysia is Sarawak. This is vigorous growing, very juicy with fairly high acid 0.5 to 0.9% and sugar 12 to 16 degree Brix, and its beer large about 2.5 kg and has eggy shape. Both size and weight sorting are crucial to fulfill the high expectation of consumers who have different desired size and weight of pineapple to suit their own purpose. Consequently, pineapples farmers and distributors are required to sort harvest pineapples accordingly. However, small-scale farmers are using manual approach, for example, experienced through eye and feeling that is highly inconsistent, slow, and laborious. Besides, it is unsustainable because this manual sorting technique has challenges. For example, wrong grading, delay due to human cannot work continuously, especially during the peak production season, and farmers may have to bear extra costs to have more workers to complete the sorting tasks. Consequently, consumer may need to pay these extra costs for their purchases. There are many technologies that shaped people's way of life, especially in the modern era of the business and agricultural sectors, particularly size sorting automation and product quality classification system that aim to safeguard the consumer's interest who have very personal requirement to their purchases. For example, mango quality sorting automation using computer 2D 3D vision based and determine the sweetness using HCB color space. Another example, determine the quality of mango using charge coupled devices camera and infrared IR camera. The nutrition determination of pineapple using complex vision techniques, and finally classify the level of pineapple using RGB and HSI color maps. Therefore, in this study, we want to predict the size and the weight of pineapple using low-cost vision system. Now we will talk about the methods and materials for this project. First, the preparation of samples and equipment. Samples of pineapples with different size were used at medium to take the image of the pineapple and to calibrate the diameter, circumference, and its height. The hardware list are a laptop, web camera, black box, and lighting circuit consists of 3D SPDT switch, 6 pieces of LED, stripes, and perspex, and a box with a cover by black cloths. For software list, image processing, and neural network toolbox was used by MATLAB. The hardware design. From the figure 1, you can see that the design and develop system of the project, and also we can see the circuit lighting system and the circuit design for the lighting system. we have a laptop and the camera is connected to the laptop using USB, and we use black box to not let the light to emit to the box, and we're using lighting system to make sure that the quality of the image is good enough. For image acquisition, we can see from figure 2a is the image for pineapple when the only top lighting is on. The image is not clear and there's a shaky effect on this image. Also for figure B and C, when the bottom lighting is on and middle lighting is on. Also the picture is not clear and the lighting is so high. However, when the LED is on from the top and middle and bottom, we can see that picture is good enough and there is no shaky effect. For image processing, first step is to segment the image and remove the noise. Figure 3 shows the segment the image into binary image to differentiate the background from desired object. This step is to divide the image into 3 images based on the intensities of each red, green, and blue. We can see that the blue plane is the best threshold because it's the most contrast between what we desire object and the background. The purpose of to segment the image into binary is to make threshold. The threshold should be optimal because we want the most contrast between the desired object and the background. Second step is to segment the image and remove the noise. Figure 4 shows the segment for remove noise and clean up the image. From the top left image, the blue plane threshold, which is the best from the green and the red threshold. Then secondly, we want to hold filled and then remove the blobs on border and remove the small blobs. This step will clean up the image significantly to improve the accuracy of the diameter or the length. So the blobs are any collection of white pixels that touch to create a cohesive and distinct object. So the main idea is to have distinct object to have a good diameter measurement or a good length measurement. For measuring the diameter, we measure the diameter of pineapple by using a ruler. 2 pieces of rulers were used for measure the diameter for top, middle, and bottom position. A ruler was placed on the table and the sample on pineapple was placed on the ruler, while another ruler is used to view the diameter from the top. This method is used to prevent from the error. For measuring the circumference, the actual estimated circumference can be determined by using equation 4, where C equal pi times D. C is the sample for circumference, where pi is the ratio for circumference of the circle to its diameter, with the value is 3.142, and D is the diameter of the pineapple. For measuring the length, after the image become clean up from the noise, we will use the region props function in the MATLAB, which will verify the measured axis length of the blob in the image. For measuring the weight, single line unit work trained with Leeuwenberg market used to predict the weight. Single line unit work trained with Leeuwenberg market successfully predict the diesel fuel properties and outperform multi-layer neural network. In the equation 1, we used to calculate the weight using the length as main parameter. Weight equal the length measured in MATLAB times coefficient length plus bias. Also, we can measure the weight using equation 2, which is based on the parameter diameter instead of the length diameter parameter, which is weight equal to top diameter times coefficient top plus middle diameter times coefficient middle plus bottom diameter times coefficient bottom plus bias. We use single line network to give us the coefficient length that can predict the weight. The dataset of pineapple divided to training and testing dataset. To validate the model performance, the root mean square error calibration is described as equation 3, where y is the real weight value and y bar is the predicted weight value, n is the number of training set. Also, we want to use the root mean square error for prediction for testing data set, which is the same equation except that the n use changed to the number of testing set, and both the root mean square error for calibration will use to validate the training data set, and root mean square error for prediction will use to validate the testing set. For manual measurement, the pineapple was measured by using measuring tab, and there were have 4 parts need to be measured, which are the diameter of pineapple, height, and circumference for top, middle, and bottom of the pineapples. Table 1 shows the data for 3 pineapple for position 120. We can see from the table that we have 3 sizes of pineapple: big and medium and small. For horizontal position, we have 3 from 0 and 45 degree and 135 degree. We measure the diameter from the top and the middle and bottom. Also, we measure the circumference from the top, middle, and bottom, and the length. And also, we measure the weight of the pineapple. For software result, the length of pineapple measured by using mathematical model using MATLAB. The result showed 3 pineapple with different size was recorded and measured in pixel by using the mathematical model. The length had converted from pixel to centimeter by using equation 4, where the equation was obtained by using a ruler to estimate the length that represent each pixel. The estimated length equal in centimeter equal measured in pixel time 1 centimeter divided by 47.52 pixel. We can see from the figure how the MATLAB successfully measure the length of the pineapple. After we measure the length of the pineapple using manually and software, we want to compare the performance for both. Table 3 summarized the length were measured by using 2 methods, which is manually using meter tab and MATLAB and software using MATLAB. From the result, we can see that software measurement shows the length is a bit shorter than the manually measurement. Also, from the table 3, we see that the pineapple that has big size has length in pixel is 640.76, and we convert it to the centimeter using the equation that we described earlier, and become 13.48. Measuring the weight using single layer neural network. After we measure the length using MATLAB, we will use the length to predict the weight of the pineapple. Table 4 shows that the length equation, which is weight equal the length in measured in MATLAB times the coefficient of the length and the bias. The coefficient of the length and the bias will obtained using a single layer neural network, and we'll see the performance using we'll compare the performance if it is good or not using root mean square error prediction. As you can see that root mean square error for calibration is 0.0034, and root mean square error for prediction is 0.2854. And we also use predict the weight using the diameter for the bottom and middle and the top. And we can see that root mean square error for calibration is 0.0010, and root mean square error for prediction is 0.2708. The weight and the bias obtained in single layer mirror is described in this two equation. Weight equal the length measured in MATLAB time 0.07112 plus the bias, which is 0.1843. This is the equation for the length. For the equation of predict the weight using the diameter is top diameter time 0.0644 time middle diameter time minus 0.1328 time bottom diameter time 0.1740 plus the bias, which is 0.0064. For conclusion, a simple vision system was designed and developed using CST camera and several LEDs for taking the image of pineapple for size of length, diameter, and circumferences, and weight prediction. The size and weight for indexed pineapple were predicted using vision system and single layer neural network. Sample of pineapple should be high to get more accurate result for prediction of the weight using single layer neural network. As we can see from our result that the sample should be more to have a good result, or will be underfitting when we have low RMSC and high RMSC for prediction. So in future study we want to increase the number of samples so that we can have a good result of root mean square error. Also, there are improvements can be made for this system to get the accurate result by using better web camera to get better quality of image, and study other algorithm to possibly improve the accuracy of these methods. For question and answer section, the question is, what is the potential scalability of project if another type of fruit is used, or if another condition are applied, no including box or similar? The answer: the research we demonstrate the use of physical vision measurement approach. As long as the shape of fruits are similar, the proposed solution is transferable and scalable directly or with minimum recalculation. External conditions have negligible except stray light that must be eliminated. This is the reason that we use the black enclosing box in this study. Nevertheless, one of our future works will be to eliminate or minimize the effects of stray light mathematically. Thank you so much for your listening.